With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
In this question, it is given that a uniform rod AB of mass m, length L, is hinged at midpoint C. The left half AC of the rod has linear charge density minus lambda, and the right half CV has a plus lambda, where lambda is constant. A large non-conducting sheet of uniform surface density, this sigma, is also present near the rod. Initially, the rod is kept perpendicular to the sheet. The end A of the rod is initially at distance D. Now the rod is rotated by a small angle in the plane of the paper and released. Prove that the rod will perform SHM and find its time period. So we have to find the time period, and also we have to prove that this will perform the SHM. So we can see that this is the D distance. So we can see from here, this is what D distance, clear, and this is what we can see, this is the sheet. This is the sheet, infinite sheet we can see, and the surface charge density is what, sigma, clear. And we can also see that this length is what, L length of the rod, clear. So this is what L length, we can see that. So this is what, L by 2, and this is what, L by 2 we can consider, clear. Now let us consider it rotate with a small angle, and this is equal to what, theta. This small angle, this is what, theta. So let us consider from here, we can see that this left half is what, charge density minus lambda, and this charge density of the right half is what, plus lambda, we can say from here, clear. Now all charge, we can consider all negative charge concentrated at this point, and the all positive charge concentrated at this point we can consider, and the distance between these two is what, L by 2 we can consider, clear. Now it displays by an angle, a small angle, theta. So we can see that this force on this will act in this direction, in this half, and in this half will act in this direction. So we can see it will try to rotate in this direction, means torque is acting about mean position. It means we can see that it will perform the SHM, clear. Now also we have to find the time period. So before that we have to find the torque. So torque is equal to what, as we know, this is equal to PE and sine theta. And for a small value of theta, for a small value of theta, we can write this sine theta is equal to theta. So from here we can write this torque is equal to PE and theta, we can write this, clear. Now P is what, we can say P is the dipole moment, and this is equal to charge. So we can see minus Q charge is here and plus Q charge is here, we can see, clear. Now P is equal to what, any charge, and separation of charge is what, L by 2. So we can take, this is the Q into L by 2 we can take, and E we can take, and E due to this sheet we can write this is equal to sigma, and divided by, we can write 2 into epsilon naught. This is the electric field, clear. Now and sine theta, this is theta, we can write here. Now Q is equal to what, Q we can write, and this Q is equal to, we can write from here, this is equal to surface charge density into length, and length we can take, this is equal to L by 2 we can write. So this is what Q we can write, clear. So surface charge density lambda, and this L by 2 we can take. This into, we can write L by 2 into, we can write sigma, and divided by 2 into epsilon naught into theta, we can write, clear. Now from here we can write this torque is equal to, we can write lambda into L square into sigma, and divided by 8 into epsilon naught into theta. This is what torque, clear. and this torque should be equal to I into alpha, where I is the moment of inertia of the rod. So we can find the moment of inertia of the rod, and this is equal to ml square and divided by 12. So this lambda into L square into sigma and divided by 8 into epsilon naught is, and theta is also here. So this is what theta we can write, and this is equal to ml square and divided by 12 into alpha we can write here. So from here we can see L square and L square cancel out. So 4 2 ja 8 and 4 3 ja 8. So alpha is equal to, we can write from here, lambda into sigma and divided by, we can write this is equal to, and 3 is also here. So 3 into lambda into sigma into 2 into m into epsilon naught. This is what alpha we can write, clear? Now this should be equal to, and theta is also here, clear? So from here we can write, so alpha is equal to this. Now alpha is equal to what? Omega square into theta, and this should be equal to 3 into sigma lambda into sigma and divided by 2 into m into epsilon naught into theta. So from here we can write omega square is equal to 3 into lambda into sigma and divided by 2 into m into epsilon naught, we can write here. Now omega equal to, we can write from here, omega is equal to root under 3 into lambda into sigma and divided by 2 into m into epsilon naught, we can write here. Now from here we can write, now we have to find the time period. As we know, time period t is equal to 2 pi, and we can write this is equal to 2 pi by omega, we have to write. 2 pi by omega is the time period. So from here we can write this is equal to 2 pi into omega value, we have to put 1 by omega value. So 2m into epsilon naught and divided by, we can write 3 into lambda into sigma, clear? So this is what time period we can see from here, clear? So this is what time period, and time period is equal to this, clear? Hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.